Hello, my name is Jorge Oviedo, and I'm going to be talking about project development processes. Primarily, I'm going to be talking about 4 different kinds, looking at their pros, looking at their cons, and comparing and contrasting them. First of all, we have the waterfall model. The waterfall model is a classical approach for projects that are linear or sequential. So what this means is that the phases depend on the previous phase. So you have 6 different phases. You start off with your requirements, and then you go into your design, and then design depends on what was the end result of requirements. And then after that, you go to development, which depends on the design. And then testing depends on the development. And then deployment on testing, and then maintenance on the deployment. So it's a sequential and linear thing, as you can see on the chart in the first waterfall summary. The pros for waterfall are that the requirements are very well defined. So requirements are not going to change throughout the whole development process. And based on this, you have no financial surprises. Nothing is going to change in money-wise from what you predicted at the beginning till the end, because there is no changing or variables in the project that are going to change the client's demands. This being so, the timeline is very easy to manage. You know when the deliverables are going to be set, when the final deliverable is expected, and you can split it up into multiple deliverables. Like I said, it's very easy to manage because everything is kind of set in stone. And finally, this is very good for well-established technologies. This being so that it's so well-defined that using something that is also well-defined to drive it through would be the best approach. For the cons for waterfall, it takes a long time to deliver because, like I said, in order to get to deployment, you have to go through testing, through development, through design, and through requirements. So you have to go through all those phases before you can deploy and maintain. It lacks flexibility. You can't change a requirement midway because everything is designed. Everything has already been done. If you change the requirements, we have to go through the whole design process again, through the whole development, testing, and deployment once again. So changing a requirement is basically starting over. And then the requirement definition, it's kind of hard for a project that you're just barely grasping in your head. Because sometimes you don't know all the requirements of everything you're going to need for your end result. So that wouldn't be a good project to use waterfall on. And then mistakes are costly. Like I said, you make a mistake in testing and you figure it out, you have to go all the way back to development and then do everything again. Or you make a design mistake and you don't catch it until deployment, you have to go all the way back to design and then redo the whole thing linearly. All right, so in summary, the projects that use waterfall need to be very, very well defined from the beginning. The waterfall method is best suited for companies that are trying to remake their legacy systems, such as let's say Chrome was trying to remake, or Google was trying to remake Chrome into a better engine. They have everything they need set in stone. Or they're porting some program from an old operating system to a new operating system. All the requirements and everything that the program has to do is already there. So it's very easy for a company to just remake that product, but better. And then you only use it on either short projects or projects where requirements are not going to change. This is not good to use on risky projects. You want to use this on very low risk projects. So our second model is our spiral model. The spiral model is based on risk driven development. So each phase starts with design goals and it ends with a client review. So you design something and then you prototype it and demo it to the client and so on. And it's a spiral motion of doing these 4 phases and then beginning again the 4 phases. So you can kind of look at it as doing waterfall multiple times. You do 4 phases, and then you move on to the next phase and do waterfall again, and then you move on to the next phase and do waterfall again. You're just repeating it without having to set in stone your beginning and your end. So some pros for this are that you identify risk early. So let's say you wanted to do a big project, but you're trying to do it with waterfall. And then not midway, but maybe midway through the development, you identify that this is not going to work out. It's too much risk, it's too much effort, but you already put all of this effort into the requirements and the design process and the development, and then you find the risk, and then it doesn't pay off. So for this, since you're looping around multiple stages, you can find the risk early and determine if this project is going to continue or fail. And then prototyping ensures that you're meeting the customer's needs. So every phase you prototype to the customer, and then the customer can tell you what is going to change or what he didn't like what he did, instead of demoing a full version and figuring out that that's not at all what they wanted. So it kind of sets you on the right track on every phase. And then requirements can change or new ones can be added. The cons for this is that since, as you can see in the picture, there is no end to this. It can go on forever and ever and ever. It is very complex to execute. You have to have trained developers in this method in order to execute it. And it is not suitable for small or low risk projects. Why would you want to try something so complex and go through all of this for a low risk project where you know you have most of your requirements and there is very little risk of it failing, so you can implement waterfall or some other method that is for low risk projects. And then time management is also difficult because you don't know exactly where to mark your deadlines. It's all reliant about what the client is gonna set. Okay. And then for the summary for Spiral, Spiral is intended, again, to be used on high-risk projects. It is intended to be complex and to make these high-risk projects either get a reward or eliminate them early on when we find the risk. Managing these types of projects is very complex, and they are usually very large projects with a lot of risk involved. So now we're moving on to RUP. This is was created by IBM. And it's called the Rational Unified Process. It consists of 4 phases, the 4 phases being inception, elaboration, construction, and transition. These phases all focus on something different, but they all do all the disciplines for that matter. So inception will focus on business modeling, requirements, and analysis, but it will also implement, it'll do project management, it will do tests, it'll do implementation, in all the different levels. And then elaboration will also do some business modeling and requirements, but it will focus more on the analysis and the implementation and the testing. And then construction will still do some business modeling and some requirements and some design, but it will focus majorly on implementation and testing. And then transition will focus mainly on testing and deploying and configuration and management and everything that's needed in order to deploy. So all of these phases are doing a little bit of everything, but focusing on a specific discipline. So the pros for this is that it's a very complete methodology. It does everything very well, and it allows you to document everything pretty well because you're doing everything very early, meaning that all your testing can be documented because it started very early rather than doing your testing at the very end and doing the test of the whole project. You're testing in batches, as you would say. And then the development time is reduced by sharing these disciplines. You're doing the testing at the same time as the implementation is at the same time as the analysis. So you're able to do and mark all of these down rather than jumping up and down, and some developers may forget what they have already done and now they have to go back and test it, and that time is going to be lost. So this way everything is done at the exact same time, a little bit of everything, and that allows time to be reduced. You assess risks as the development moves and incorporates new and changing requirements. So as development moves, changing requirements is not as bad because you have done already a bit of everything. So if a requirement changes, you don't have to go back and change everything. You're still working on everything at the same time. And then integration happens simultaneously. You're integrating everything together as you're coding through these phases. And then the cons, you must undergo RUP training or have significant experience in RUP if you want to be successful in this methodology. This is very intense work, and it's very complex, and if it's not executed properly or by someone with knowledge, you're gonna end up with very disorganized and very dirty code. So that's another one of the cons, that it can be, even if you know what you're doing, it can still be very complex and very disorganized. And then although integration seems like awesome, we're integrating everything at once, it doesn't always necessarily work out that way. Integration is also a very difficult process, and it's happening at the same time that everything else is happening. So again, if you're not familiarized with the process, it can be very difficult to integrate what you're doing. So summary for RUP, it is great for big organizations that know what they're doing, that have trained their engineers into knowing how to use this process and that work this way. But and also for projects that require extensive documentation. Say a project that is immense and requires everything to be documented in order for the user to be able to purchase it and be able to understand it without undergoing any training, or be able to reference the documentation and have great documentation. This is the methodology you would want to use. It requires very adept developers. Again, like I said, you have to know what you're doing in RUP. You have to understand how everything is working and how to implement everything together at the same time as going through the RUP methodology. So if it's executed improperly, it can cause more harm than good. So moving on to the final methodology, we have Agile. So Agile is what is mostly used in companies today. It is made for continuous development and delivery. This means that it consists of 6 recurring phases. It starts in the planning phase. It moves through the design, development, testing, release, feedback, and then loops again back. So what's happening here is that these phases are repeated and the software is being delivered in batches. The software is being delivered as a working software. So it's very easy to put this into market. So that's, we're going into the pros now. So risk and change are easy to manage because you're going and basically doing a new iteration of Agile every time you finish the old iteration. So you implement the feedback, you implement the new requirements, you implement the new features into the software as you go. So managing risk and change, really easy. You're continuously delivering software. Your software is improving every 2 weeks, every week. You're getting a new version and a new version with new updates and new features. It promotes teamwork because it does not allow a developer to become focused on just one portion of the program. The developer is focused on tasks, which are broken down. So a developer can do a task for the GUI and then do a task for the backend and then do a task for the server. And then it's working on all different fronts at the same time. So a developer becomes more familiarized with the code, and teamwork is more prevalent in this regard. And then constant communication is required among teammates, so this also promotes that. It allows all teammates to communicate with each other, and it's less upfront work. You don't have to code the entire module or code an entire class. You do a batch, and then someone else is going to do something else, and everyone works off of each other. The teamwork actually really helps in Agile development. The cons for this is that, again, there's no end. It's a loop, and it can loop on forever and ever and ever, and at some point, the cost, is it really worth keeping the development? So that can come into play with management. Poor planning, because you don't know what's coming 3 loops ahead. So you know what's in this Agile loop, but maybe 3 weeks down the road or 3 loops down the road, you have a massive update that the customer is going to want, and you need to plan ahead for your engineers, for your headcount, for everyone to be able to work on that. So planning is a bit difficult because you don't know what's coming. You don't have a finite timeline. And then you can also end up with fragmented output. One of the pros can become a con. If a developer is working on something and he finishes his task and then someone else continues working, you can see 2 different portions of code. One done by someone else, one done by the first person, and these 2 codes don't necessarily have to match. Like it can be 2 completely fragmented outputs that don't correlate at all, because they were done by different developers and the teamwork and the communication was just not there. The other thing is that there can be lack of documentation, because since there is no one person working on one specific thing, he will only be able to document his portion, and there's not going to be someone that documents the whole thing as a whole. So documentation can be lacking if it's not taken into account. And also, it's not suited for big teams. This is great for small teams where everyone can talk, where everyone can communicate with each other. But if you have a team of 100, 200 developers, you won't be able to talk to each one and see what they're doing. Managing the project is going to become hard. So it's not suited for larger teams. So as a summary, Agile works best in an unpredictable environment where you don't want to plan out, where you don't know what's coming. So you use Agile in order to keep moving with the technology, and not stay stagnated by taking a year to develop something that might be obsolete in that year. So you deliver something fast, you make it market ready, people can start using it, and then you evolve it as the market and as the technology evolves. And then Agile can bring products to the market fast. Again, once you finish the first iteration, the project should be deliverable and it should be able to hit the market. And I believe that's the greatest value in this, that you're delivering stuff to your customer and your consumer on a regular basis. But that was it for Agile. So in summary, for all of them, each methodology has its pros and its cons. It has ways to be used. It depends a lot on what you're doing, who's doing it, and how. So a big team can lean towards one methodology. A small team can lean toward another. A big company can lean towards something that's different because it needs the specific documentation. So all of these methodologies are worthwhile, and they are all unique and good in their own way. Thank you. This was my presentation, and hope you enjoyed.